As you might know, I'm one of the Beam Summit organizers. Some people will know me in the room. But in a previous life, I also spent some time developing Beam pipelines. And this morning, I'm going to briefly present what I did at the time at Dataflow, where we developed a solution using Apache Beam for a company called Sky. So before we kick off, maybe for the Europeans in the room, this might be a bit of repetition, but Sky is a major media company in Europe. They have 22 million subscribers across UK, Italy, Germany, and Austria, and they provide a lot of products, going from TV, broadband to phone, mobile services. And as you will see, the solution is kind of Google Cloud focused, and this is because back in 2017, Sky decided to use Google Cloud for their data workloads. But yeah, most of the talk is about, I tried to keep most of the talk about Beam. So, SkyQ is the product we're going to talk about, and it's, to give you some context, is a set-top box that sits under your TV, and it's their flagship product, and you kind of interact with it with a remote, flicking through channels, or trying to find some content that you might be interested in. And what did Sky wanted to get out of that? Because you might ask the question, why are we talking about set-top boxes? So basically, all of these set-top boxes generate some events whenever you interact with them, and these events are captured and sent to the processing backend for further downstream processing to create some insights. For example, what do your users do when they are going through the UI, and what is, for example, the content they are looking for and interested in. And obviously, people are watching TV at any point in time. This kind of naturally creates a stream of data coming off the set-top boxes, and that's why Sky arrived at looking at Apache Beam. They had a Hadoop solution before, and there they were running into some problems because it was a batch pipeline, but obviously people keep watching TV overnight, and sessions got cut off, etc., etc. Data was only delivered a day later. So unbounded stream of data, Apache Beam, it kind of made sense. So they were particularly interested in some of the concepts that Beam provides, the windowing, and in particular the session windowing, because they want to look at the burst of activity of a user interacting with the set-top box. And then some of the native tools that you get with Beam to interact with late arriving data, because obviously sometimes someone turns off their set-top box and then events don't get sent to the backend for processing. And case in point, they decided to have session windows with a 4-hour inactivity gap and a hard cutoff at 24 hours, because some people keep watching TV or clicking buttons, and yeah, at some point you run out of memory, so you need to stop your session. Cool. So a side effect of people watching TV, it's kind of an erratic pattern throughout the day, because during the day most people are out at work. At night people turn on their TV, so more events get generated, and that's how you kind of end up with this thing. On the weekends as well, more people spend more time, more events get generated. And this is also one of the reasons they chose to go for a particular runner, which is a Dataflow runner, because it comes with kind of a serverless architecture where you don't need to worry about the ops. Your cluster will auto scale whenever more data arrives in your pipeline. So they were really happy about that as well. So as a consultant, we went in and we tried to think about how can we help the people to solve this problem and have a nice processing pipeline. And we wanted to get an end-to-end solution. So data gets produced on the set-top box. We wanted to know what schemas the data would come in. So we wanted to talk to the people that design the firmware of the set-top boxes, because obviously if you don't know what they're going to produce, you kind of will run into some problems when you're processing the data, and some messages get lost because you want to act on a particular schema. And on the other hand, we wanted to know who our customers were. For example, what questions do they want answered? How frequent do they want their question answered? Is it fine if the data is delayed by a day? Things like that. So we tried to get some buy-in from everyone in there before we started designing the solution. So what did we come up with? This is kind of where I dive into the technical architecture, and we'll describe the different sources and how we went about processing the data. So we had the set-top boxes, obviously, where the fact data gets created. And these are the actual events that went into the pipeline. But another important source of data was the dimensional data. So reference feeds of their existing customers that we kind of needed to create useful insights further downstream in the pipeline. Obviously, we needed to ingest this data into our processing systems, and this is where the ingestion comes in. So for the data in motion, we ingested the data in Google Cloud PubSub, and for the reference data, everything was staged into BigQuery. And then this is where Beam comes in, finally. We have the unbounded stream of data coming off PubSub, and we decided to process this using Beam on top of Google Cloud Dataflow. So we have the first pipeline here, which we called the processing pipeline. And that was a pipeline that took care of parsing the data. So we were looking at enforcing the schema, logging faulty messages to a dead letter queue, filtering some data, and most importantly, we took care of the sessionization in there. This data was then written to BigQuery, and we used BigQuery to do the intensive joins, the heavy lifting of the joins between the reference data and quite a lot of the fact data. So yay, we have everything sitting in BigQuery now. We call these the raw joined events because they were enriched with the reference data. And then we ingested them into what we called the enriching pipeline, where we applied some more complex algorithms to actually look at the user sessions, because you have a bunch of events for example, me watching an hour of TV now, but what can we actually get out of that? Like, what menus did I visit? Where did I decide to actually watch something? Or at what point did I churn and turn off my TV and go do something else? So that's what we looked at in the enriching pipeline, and that's also where, for me, it was kind of cool to use an imperative language, in this case Java, instead of something like SQL, because you needed to look through the events, look at different things that were happening there, and that was kind of easier to do in Java than in SQL. So kind of framing what we decided, we made some decisions in both pipelines, kind of framing it by the 4 questions everybody asks when designing a Beam pipeline. So what were we computing? In the first pipeline, it was element-wise transformations, so just the filtering, the sessionization, filtering and some things like regular expressions. While in the second pipeline, we looked at the group of events and then processed them. Where in event time, I already went through that as well. We choose session windows, and then when in processing time, this is where the triggers came in. We had an early trigger set up for after 24 hours to get rid of the session when it was overrunning. We had the normal after watermark trigger, and then we had late triggers in case data would arrive. And last question, we just used discarding panes to clear the buffer whenever the next thing arrived. Cool. So moving on to the users of our data, because that's where we actually cared about. So we kind of split it up across advanced data users, where we had people using the raw events coming out of the processing pipeline. So they were people that could write their own queries, do their own joins if necessary, and they could benefit of the low latency of the data arriving into BigQuery. While the normal data users use the data coming out of the enriching pipeline. So there were people that kind of could were self-serving using BigQuery and writing their own queries, but they were happy that some of the work was already done for them. And then lastly, we had the dashboard users, which were the people that kind of got their Tableau dashboard in the morning. All of the stuff was already calculated for them, and they could just look at the dashboard and see what happened the other day. So, kind of looking at the overview, we have the ingestion of the data, processing of the data, usage of the data, and obviously there were some other things that needed to happen, which was monitoring, which we used Stackdriver for, and orchestration of the joins, for which we used Apache Airflow. And I want to highlight that I think, well, it's kind of a GCP heavy thing, heavy architecture, but for example, PubSub we could potentially replace by Kafka, BigQuery we could potentially replace by Drill, and monitoring we could, for example, use Grafana. So I think it's perfectly possible to do this in a more open source approach, but Sky was happy to have some of the things done for them rather than having to do it themselves, which was, yeah, everybody happy. So looking at where we came from, on-premise static size cluster to no-ops streaming pipeline on Google Cloud Dataflow made them happy as an engineering team, but them as well as a customer. So overall success, and I hope this is probably the least technical presentation on the Beam Summit, but I hope this kind of brings the users as well to where the people in the project kind of produce the code. So yeah, thank you.